Hey everyone, quick video on the integral test, section 11.3 in Stewart. Recall that the integral test is a test for convergence and divergence. And that the criteria are that a series with a general term that is positive, continuous, and decreasing converges if and only if its improper integral converges, which means that also if the integral diverges, then the series diverges. Let's look at an example. First, note that the term 6 over x ln of x is continuous, positive, and decreasing on the interval 2 to infinity. Note that it's got to be 2 to infinity, not 1 to infinity. Otherwise, we'd be dividing by 0. So here, since we verified the conditions, we can use the integral test. So we're going to write, since the integral from 2 to infinity of our general term, now remember, we like to use x's instead of n's when we integrate. Since this is going to either converge or diverge, so is its series. That's where we're going with this. Remember, you have to immediately write the limit as t approaches infinity and replace that infinity with t. You have to do that. Okay, so we're going to take the integral of this, and I'll just say, using a u substitution, where u equals ln of x, which means du is going to equal 1 over x dx, you're going to wind up getting that this equals the limit as t approaches infinity of ln of t. Oops, I guess there's a 6 in front, isn't there? Minus 6 ln of 2. Which diverges. Now let's look at our sentence here, right? Since this integral equals this, which diverges, so does our series. Oops, I guess the sum is from 2 to infinity. Okay, that's how you do the problem. Remember, always make sure to cite the test that you're using and state the answer. Next up, we've got a very nice fact, another test for convergence or divergence called p-series. You can, of course, find this in your book, page 717. P-series states that if you have a series whose term is 1 over n to some constant p, then that series converges if p is greater than 1 and diverges if p is less than or equal to 1. Now, the proof is that we use the integral test. To use the integral test, we're going to integrate this general term. We're going to see in one case the series converges, the other case it diverges, right? There's going to be a special case for the integral of 1 over x, because that's ln of x, but we'll just keep that in mind. Consider the series from 1 to infinity of 1 over n to the p. Since the term 1 over x to the p is positive, continuous, and decreasing, we can use the integral test. First, consider p not equal to -1, because remember, that's special integral, right? That's ln of x, right? So what we're going to have is the integral from 1 to infinity of 1 over x to the p dx, which of course equals the limit as t approaches infinity of the integral from 1 to t of, I'm going to write this as x to the negative p dx. And this is going to equal the limit as t approaches infinity of 1 over 1 minus p x to the 1 minus p from 1 to t, which is going to equal the limit as t approaches infinity of 1 over 1 minus p times t to the 1 minus p minus 1 over 1 minus p times 1 to the 1 minus p. And when we simplify this out, I think it's probably better to write this as the limit as t approaches infinity of 1 over the quantity 1 minus p t to the p minus 1 minus, and then this is just 1 over 1 minus p. And I think if you take a look at this, you can see that this converges if p is greater than 1 and diverges if p is less than 1. Now, consider p equal to -1. So, really we have the integral from 1 to infinity of 1 over x dx, which equals the integral, which equals the limit as t approaches infinity of the integral from 1 to t, 1 over x dx, which equals the limit as t approaches infinity, ln of x from 1 to t, which of course equals the limit as t approaches infinity, ln of t minus ln of 1, which we know that latter term goes to 0, which diverges. All right, and then just to state the conclusion, which we should always be doing, let's shrink this a little bit. So the sum from 1 to infinity of 1 over n to the p converges if p is greater than 1 and diverges if p is less than or equal to 1.